Hi everyone. To help you study for the midterm, I've put together a list of tips that I'd like you to keep in mind to prevent you from making the common mistakes that I always see. First up, P of n is a predicate, not a number. So don't write this or this. Don't do that. Next, state where you use the induction hypothesis. Remember, in our proofs, we want to see the words by the induction hypothesis somewhere in your proof. However, a lot of students just stuck it in at the end, and they wrote something like, by the induction hypothesis for all n p of n. This is wrong. The induction hypothesis is used somewhere in your induction step proof. But it's really the principle of induction itself, and not just the induction hypothesis, that allows you to combine the base case with the induction step. Moral of the story, the induction hypothesis appears somewhere in your induction step argument. It doesn't appear at the end of your proof. Okay, some people made this mistake. They perfectly said where the induction hypothesis was used, but in their proof they never said what the induction hypothesis was. That is, they would use an assumption, the induction hypothesis, without actually saying what the assumption was. This makes your proofs extremely unclear. Know which values your induction step works for. Remember that your induction step should start with let k be something, and then assume p of k, or p of 0 through p of k if you're doing complete induction. This part here is easy for you to skip over, but it's very important because it tells your reader exactly which values your induction step works for. Is it all natural numbers? Is it k greater than or equal to 3? Or greater than or equal to 14? Don't just start off by saying that k is a natural number and then later saying, oh, k is greater than or equal to 14. No, you say so up here, not down here in your proof. Okay, this one's pretty straightforward. Don't confuse the three types of induction. Simple, complete, and structural induction all look different. And if I specify which one I want you to use on a test question, I expect you to use that type of induction. On the other hand, if I don't say what type of induction to use, I also expect you to be able to figure out which type of induction you're supposed to use. Okay, this is a mistake that a lot of you make, even when you actually know what's going on. Don't write long-winded explanations. Keep your proofs short and to the point. What am I proving here, and why is this true? Every time you write a sentence down in your proof, ask yourself these two questions. And if you can't answer one of them, then there's a good chance that that sentence is either irrelevant or unclear. And either way, you should take a second look. But on the other hand, don't make your proofs too short. Justify your claims. Everywhere you use some reasoning that's not just basic math, say why your statements are true. If you ask yourself, why is this statement true, and it takes you longer than 2 seconds to think of the answer, you better write down that justification. This is a common misconception that I talked about in lecture, but I'll repeat here. Finding a pattern isn't the same as proving it, or even justifying that it's right. Just claiming that you find a closed form, for example, or a recursive definition. Simply writing it down is not a proof. Saying that, oh look, it works for f of 0, and for f of 1, and for f of 2, and for f of 3, and you know what, I even tried f of 4, and the pattern still held. That's not a proof. That's not even justification. And in particular, when we ask you questions about sets or about strings, the justification that we're looking for has to do with the sets or the strings, not about the pattern that you found, not about the small values that you tested. Okay, repeated substitution mistakes. I mentioned these in class. First one, don't drop the non-recursive part when you're doing repeated substitution. Repeated substitution changes f of n minus 1 to f of n minus 2 plus 3. Don't forget about the plus 3 here. Second one, if the non-recursive part also contains an n, make sure you change that n as you're doing repeated substitution. Over here, this should really be n minus 1, and then n minus 2 plus n minus 1 plus n. And last but not least, you should only have closed form expressions in terms of n, so I don't want to see this. And they shouldn't have summations, because the summations that you'll see in this course have a much simpler form. And as a bonus tip here, I'll just say, review logarithms. I won't promise that there are logarithms on this midterm, but even if there aren't, you'll see them again in this course a lot, and in future courses a lot. So if you're uncomfortable with the logarithm work we've done in class, now's your time to review that. And that's all. Good luck with your studying, and have a great day.